This section is over transformations, and it is just like it sounds. We are going to transform something. So if you are one of those people that like to play with transformers, then hopefully this section is for you, because that's exactly what we're going to be doing. Okay, before we actually transform something, we need to figure out what in the first place are we actually transforming. And so we're transforming graphs, but we need to have a foundation, a set of graphs that we can transform, and so we need to start there. And so there's actually 7 basic graphs that I want you to have identified by the end of this section. We're going to start first here with the polynomial graphs. There's 3 of them. And so you can see why I define these as polynomial graphs is because my function is in polynomial format. It's x to some power, so on and so forth. Notice these are basic, hence the name of basic functions. There's nothing added, subtracted, multiplied, divided, or anything extra that goes with them. So what we want to do is we want to identify what their graphs are, and then beyond that, we want to specifically talk about the x-intercepts, y-intercepts, domain, and range. So in this slide here, we're going to talk about what the graphs look like. I'm hoping with the first 2, y equals x and y equals x squared, you already know what those graphs look like without me having to give you much more information. The third one might be a little bit more complicated, but I'm hoping that you can figure it out on your own. So I would like you to pause the video and try and come up with these basic graphs on your own without utilizing a graphing calculator. If you don't know what they are, then I suggest that you plug in points. Plug in the value for x and see what the corresponding y value is. Plot those points on the graph and then connect the dots, and that will give you the graph of your basic function. So here's where you pause that video and you do that on your own. Okay, so with the first one, y equals x, it is a line because it is a degree 1. It's a linear function. If I plug in any x value, I'm going to get out the exact same y value. And so this is my corresponding line. This is the graph of y equals x. In the second graph of y equals x squared, you should notice that it is a degree 2 polynomial. Hopefully you remember that the degree 2 polynomial is a parabola, which is the shape of a U. Now, if you don't remember exactly where the U is, that's where we can plot in points. If I plug in 0, I get out 0. If I plug in 1 and I square it, or negative 1 and I square it, I get out 1. If I plug in 2 and I square it, I get out 4. If I plug in negative 2 and I square it, and I get out 4. Hopefully these are enough points to give you the general shape of this graph, which is a U or a parabola. Now, the third one might be a little bit more complicated because we haven't specifically talked about it yet. We will talk specifically about degree 3 and higher polynomials in the next chapter. So this gives you a great foundation for that chapter. If you don't know where to start, again, I suggest by plugging in points. If I plug in 0 for x, what do I get out for y? And that's 0. If I plug in 1 and I cube it, I get out 1. If I plug in 2 and I cube it, I get out 8. What happens if I plug in negative values? If I plug in negative 1 and I cube it, I get out negative 1. Negative 2 gives me negative 8. And so hopefully these points here are going to be enough to give you a general shape of the graph. And so if we connect the dots here, we get this image that looks like this. So in perfect format, here is the shape of your basic polynomial functions. Degree 1 is line, degree 2 is parabola, and this is what the degree 3 looks like. Now, not only do we need to do these with polynomial functions, but we need to do these with other functions as well. And so let's look at these other functions here. I've identified the 4 other. Square root of x, 1 over x, absolute value of x, and then the cube root of x. So again, I would like you to come up with the shape of these graphs on your own without using a graphing calculator. You're more than welcome to check with the graphing calculator. And if you don't know where to start, then I would start by plugging in the points, just like we did with the x cubed. So pause the video and try and do that on your own. Okay, square root of x. If I plug in 0 for x, I get out 0. Square root of 1 is 1. I can plug in 2. It doesn't give me a pretty number. I can plug in 3. It also doesn't give me a pretty number. If I plug in 4, I know the square root of 4 is 2. And so let's start there. And my 3 is a little off. And so we get this here. So it should resemble this shape. Okay. What's happening on the left-hand side of the graph? Well, what happens if I plug in -1 and I want to take the square root of -1? Well, we know that we cannot take the square root of negative numbers. So that is an imaginary number. It's not on my graph. Same thing with any negative number. They're all imaginary, and so they won't appear on the graph. And so this is where my graph is. Y equals 1 over x. If I plug in 1, I get out 1 over 1. If I plug in 2, I get out 1/2. If I plug in 3, I get out 1/4. What happens if I were to plug in 0? 1 divided by 0 does not make any sense. It is undefined. So I don't have anything for 0, but I do have a point at 1, 1, and then 1/2, and then 1/3, and 1/4, and whatnot. What about the left-hand side of the graph? If I plug in -1, I get out -1, and then -2 gives me 1/2, -1/2, -1/3, -1/4. So you might have an image here, but I think we could do a little bit better. What happens if I were to plug in something between 0 and 1? So what happens if I were to plug in 1/2? That would be 1 over 1/2. Well, we know to divide fractions, I flip and multiply, so that's the same thing as 1 times 2. That would actually give me 2. So if I plug in 1/2, that would give me 2. If I plugged in 1/4 in the same fashion, that would give me 4. If I plugged in -1/2, that would give me -2, and -1/4 would give me -4. And so this gives me this portion of the graph, and this gives me this portion of the graph. Notice my graph gets closer and closer to the y-axis, but it actually doesn't touch it. And it gets closer and closer to the x-axis, but it actually never touches it. We'll learn more about that in the rational function section, again in Chapter 3. But right now, all we need to know is this is the shape of the basic graph 1 over x. Y equals absolute value of x. Remember, absolute just makes things positive. So 0, 0. If I plug in positives, all of my numbers are going to stay positive. If I plug in a -1, I'm going to get the positive version of it, which is 1. So -2, 2, and then whatnot. And so the shape of the absolute value graph is actually a V shape. Notice I don't get anything down here because absolute value is going to make things positive. So I should never have any negative values on this graph. And then last but not least, the cube root of x. So I'm just going to go ahead and fill in some points. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of -1 is -1. And then I would go over to the cube root of 8, which is not going to be on this graph, but I can guess that's going to be 2. And then the cube root of same thing over here. And so it's going to have this shape here. And so that's the shape of the cube root of x. Okay, so here's the picture-perfect images of these graphs here that hopefully you found on your own. And so if I were to look at all of these basic functions at once, these would be the images for all 7 of them. So these are the 7 images that we hope you to have a very good understanding of in this section, because we will be working on transforming these images. So we can't transform them if we don't know them. So we need to get really familiar with them first. That's what we're going to do in the next video, is we're going to get really familiar with these by identifying all of their x and y intercepts and their domain and their range. So if you don't remember what those are or how to find them, this would be a perfect time to review them.